Hey, it's Felipe from Flow, and today I'm going to show you how to use the on-chain randomness with Flow. Specifically, we're going to do a Cointoss project. This project demonstrates how to safely use random numbers in smart contracts. And why is this important? Because in the blockchain, everything must be transparent and verifiable, which makes it really, really hard to be able to generate random numbers. This project shows the proper way to do it on Flow's blockchain. So the first thing that we're going to do is have a scheme called a commit reveal scheme. Basically, what happens is that we have two steps. In the first step, we do the commit, and for the coin toss, we are going to flip the coin, and we are going to make a bet, basically deciding how much flow tokens we want to bet. And then the contract will give us a receipt, which is imagined as a lottery ticket, and then the contract records what the block, like when this happened with which block. Then we have the second part, the second step called the reveal, and this is where we see the results specifically. We have to wait at least for one block to pass, which is a couple of seconds. And then we present the receipt back to the contract, and the contract uses a random number from that future block. So if you win, there's a 50-50% chance you get double the money you put in with the bet. And if you lose, well, then the contract keeps all your bet. So why are we using two steps? Because basically a cheater could come in, call the contract, see that they're going to lose because all the functions have to be, verified. They have to be deterministic. So they could basically see that they're going to lose and then cancel the transaction. But with a commit reveal, once you commit, you can't go back. You can't, backpedal. You already placed in your bet, and that is locked in. So basically what happens is that we have these two main contracts, which are the flip coin and the reveal coin. The flip coin is the commit aspect of the VRF, while the reveal coin is the contract which does the reveal. We're going to be able to run this on testnet. First, we need to interact with the Flow CLI in order to create a testnet account. So we're going to go with Flow. We're going to run Flow accounts to create. And then we're going to have a name for our testnet account. For the matter of this tutorial, we're just going to call it Cointoss testnet. We're going to select testnet. And now that once we have our account, we can see it was successfully created. Okay, once we have created our testnet account, we're going to select the testnet address and then go to the Flow faucet, insert the address, and we're going to fund the account. Perfect. And now we're going to send this transaction, which specifies that we're going to bet 15 flow tokens in the testnet. And the signer of this transaction is going to be the testnet account that we have created, the Cointoss testnet. Fantastic. Now that the transaction went through and it is completely sealed, we can go through it. We can verify that it's completely sealed. This is the transaction ID, which if we copy and we paste it into flowscan.io, we just need to make sure that's in the testnet. Then we go to the events, we'll be able to see everything that happened. For example, the tokens withdraw, we'll be able to see that the amount we were betting is 15 flow tokens. And then we are requesting randomness at this specific block. And this is the unique number for our randomness request. This same information can be viewed in the terminal. We can view the amount we bet. We can view the block it was betted at and the unique identifier for the randomness. Now, if we run the following command, the flow transaction send, and then we do the reveal coin transaction, and we specify that we want this testnet address that we created to run the command, we can see we already have a transaction ID that we can copy. And paste in our flow scan, and then we can see everything that happened. For example, in this part right here, the randomness sourced, we can see what are the bytes, the random bytes that were given within the previous block. Then the result of this coin toss. Here, the result is 0, which means that we won the bet. If the result were to be 1, then it means that we would have lost the bet. And then we can see the amount that we have been deposited with. We are withdrawing these flow tokens specifically from the contract. So it's pretty great. We were able to bet 15 flow tokens and we won 15 flow tokens. And all of this using complete VRF. We were able to access on-chain randomness without it having to cost money or for it to take too long, and it is completely safe. And so here I can see specifically, this is the commit aspect where we use the flip coin transaction. And if we look back into the unique identifier, which starts in 6926, we can go to FlowScan with our reveal transaction and look that the request is also 6926. That's how they are linked. On-chain VRF is super, super cool because many blockchain games have been hacked precisely because they have poor randomness. This implementation shows how an industry standard way to do it. And this could make games provably fair for everybody. This commit reveal pattern could be used for lotteries, NFT mining, gaming, auctions, any scenario which requires fair, unbiased randomness. I hope you guys were able to learn something. See you next time.